Assalamu alaikum warahmatullahi wabarakatuh. Good morning everyone. How are you? I'm Jan Ahmed Sadiq and today's topic is about physics and measurement. Now, first of all, what's the meaning of physics? Physics actually is a science, is a branch of natural science that deals to the study of the nature of matter, energy and their interactions. And also it is a way of observation of the world around us. Physics, as we said before, that physics is a branch of natural science. But because of science can be classified into two, natural science and social science. And natural science can be classified into three, the three main branches, which is physics, biology, and chemistry. Physics is a branch of natural science, where natural science are classified under science. Okay, and also there is a relationship between physics with the other sciences, with the other natural sciences. Like for example here, biophysics, astrophysics, and geophysics. Biophysics means it is a combination between biology and physics. The same thing with astrophysics, that it is a combination between astronomy and physics. The same thing with geophysics, which is the combination of geology and physics. There's also another relationship between physics with the other sciences. But now, after we finished and after we understand the meaning of physics and under which branch it is, now let's go to the meaning of measurement. Now let's continue by the use of measurement. First of all, measurement is one of the activities performed in physics. And also we can use measurement in the physical quantities, where physical quantities that can be measured directly and indirectly are known as what? Physical quantities. And these physical quantities are classified into two, fundamental physical quantities and derived physical quantities, where fundamental physical quantities is measured directly and it's also known as the basic units or the basic quantities. What about derived physical quantities? The meaning of derived is different, so that means we are knowing this or call this one what derived physical quantities, different physical quantities. Now let's also see more information about fundamental physical quantities and the seven physical quantities, seven fundamental physical quantities, and derived, which is some. There is some examples about derived physical quantities because it's different from fundamental because derived are measured indirectly and fundamental are measured directly. Now, as we know that fundamental physical quantities are also can be classified into seven fundamental physical quantities, but physical quantities that can be classified into fundamental and derived physical quantities, we will see their definitions, what is the meaning of fundamental and derived physical quantities, and also some examples about them. Now, first of all, fundamental physical quantities, which is measured directly and are also called basic quantities, or we can say basic units. Here also the units used to measure the fundamental quantities are called basic units. Okay, now here's the seven fundamental physical quantities are B into basic quantities and basic units. Okay, the basic quantities, which is length, time, mass, temperature, current, amount of substance, luminance, of intensity. And the basic units is the units that we measure the basic quantities. Like for example, length by the small letter L, we can measure length by meter, right? Okay, meter, its symbol is M small letter. Okay, what about time? Time by the symbol of T small letter, and it can be measured by the unit of second, right? Second is the unit of time, and second can be like denoted by small letter s. Okay, the same thing with mass. mass by the small letter m, and can be measured in kilogram, which is kg. Now, temperature, which is denoted by the capital letter T, but time, small letter t. Now, temperature, capital letter T, can be measured in Kelvin. Actually, for temperature, we can measure it in three ways: Kelvin, Celsius, and Fahrenheit. But the SI unit is Kelvin, and the unit of temperature is degree. Okay, so the unit which you use to measure temperature is Kelvin, which is denoted by capital letter K. And what about current? Is denoted by capital letter I and is measured in amperes, which is capital letter A. And amount of substance, which is by M, capital letter M, but mass, small letter m. It's measured by mole, which is the symbol, also the same thing, mole. Okay, luminous intensity doesn't have a letter or a symbol for it, but it have a unit that can be measured in, like in candela. Candela, the letter, or it can be denoted by CD. So that was about the 7 fundamental physical quantities. What about derived physical quantities? Let's see the meaning and the definition of derived physical quantities and some examples about them. Now let's continue with the derived physical quantities. Derived physical quantities are measured indirectly, and derived means different, where derived physical quantities also known as different physical quantities. And here there are some derived physical quantities, some examples about them, like area by the capital letter A, and its unit is square meter, which is meter square. Volume, capital letter V, which is meter cube. Density, which is its letter is rho, and its unit is kilogram per meter square. I mean per meter cube, because it is a density, because density is equal to mass over volume. So that means volume, what we have here, meter cube, and mass, it was in fundamental physical quantities, which is kilogram. So kilogram over cubic meter is equal to kilogram over meter cube. Okay, acceleration, which is denoted by small letter a, and its unit is meter per second square. Now force is by capital letter F, and also its unit is kilogram times meter per second square. Pressure, it is by the capital letter P, and its unit is kilogram times meter per second square over meter squared. Now here for force and pressure, the first one, which is kilogram times meter per second square, we can say also, instead of this thing, instead of making three things, we can make it one thing, which is Newton. Kilogram times meter per second square is equal to Newton. Okay, which is denoted by capital letter N. But what about pressure? The same thing. Here, if you see up, kilogram times meter per second square, which is Newton, over square meter. That means N over meter square. So that was about some examples about fundamental physical quantities and derived physical quantities. Now let's see what's the difference between vector physical quantities and scalar physical quantities. Now let's continue by the physical quantities, which describe the number and a unit in the same time. This can be classified into two, vector and scalar physical quantities. First of all, a number with a unit is called a magnitude. Okay, physical quantities are grouped into two, as we said before, scalar and vector physical quantities. Now, a scalar quantity is a physical quantity which has a magnitude without direction. It has the magnitude but without direction. That means it has the number with the unit but without direction. Like for example, distance, power, energy, mass, and there is another things also. Not only this one, like distance, power, energy, mass, pressure, also. So there are so many scalar quantities and vector quantities. But vector quantities, the difference between vector quantity and scalar quantity is that scalar quantity doesn't have the direction, is not measured or can be or it's have a direction. But vector quantity have a direction. The both have the both the magnitude and the direction. Like for example, some examples about vector quantities are displacement, momentum, acceleration, current, weight, and so on. So this was about the scalar and vector quantities. Now, after we know the physical fundamental quantities and derived physical quantities, we will take three examples from fundamental physical quantities, and we will see their meaning and also the units, the SI units, the SI unit and the non-SI units together. Like for example, the three, which is length, mass, and time. Now, these are three fundamental physical quantities. We'll see them and we'll describe them. Now let's continue by the three examples of fundamental physical quantities. First of all, we'll start by length. Length is used to describe the distance between 2 points. The SI unit of length is meter, and the non-SI unit of length is also centimeter, millimeter, kilometer. Now, here are some examples for length, or you can the non-SI units. Like for example, 1 meter is equal to 1000 millimeters, and also 1 meter is equal to 100 centimeters. 1000 meter is equal to 1 kilometer. 1 meter is equal to 0.001 kilometer. 1 millimeter is equal to 0.001 meter. 1 centimeter is equal to 0.01 meters. And 1 kilometer is equal to 1000 meters. Now here are some examples like how to convert or how to use this non-SI units. Like for example, the distance between different two electric poles measures 100 meters. Now, what is the distance in centimeter and kilometer? Now, what we have 100 meters. Okay, so the given is 100 meter. Now we want to convert this 100 meter into centimeter and into kilometers. First of all, we'll start by a centimeter. We know that 1 meter is equal to 100 centimeter. So how many 100 meter is equal to centimeter? We can use this way. First of all, we will write the rule, which is 1 meter is equal to 100 centimeter, right? Now we'll put 100 meter under the meter, which is 100 meter is equal to 100 centimeter, right? So we don't know the centimeter. We want to convert 100 meter into centimeter. What we don't know, how much is in centimeter. So we'll make x in place of the numbers that we don't know. Now we will make the crisscross. That means 1 meter times x and 100 centimeter times 100 meters. Or you can in place of x only question mark. Okay, now what we will do, length is equal to 100 meter times 100 centimeter, right? Okay, over 1 meter. Now we'll cut meter by meter. Okay, now what we have, 100 and 100. 100 times 100 centimeters. It will be length is equal to 100 centimeter, which means length is equal to 10,000 centimeters. That means 1 meter is equal to 100 centimeter and 100 meter is equal to 10,000 centimeter. So now we know how to convert meter into centimeter. What about meter into kilometer? What we have here, 1 meter is equal to 0.001 kilometer. But we need to convert 100 meter into kilometer. So we'll put the same thing. 100 meter, which is meter under the meter. 100 meter is equal to, we don't know the number, which is in centimeter. So when we make crisscross, it will be 100 meter times 0.001 kilometer. Length is equal to 100 times 0.001 over meter, over 1 meter. Now we will cut meter by meter, and then what we have 100 times 0.001 kilometer. So that means length is equal to 0.1 kilometer. Now the final answer for kilometer is 0.1 kilometer, which 100 meter is equal to 0.1 kilometer and 1 meter is equal to 0.001 kilometer. So that was about length, how to convert the units or the SI units, the non-SI units of length. Now let's go for the mass. Now let's continue with the measuring of mass. First of all, mass, it is defined as the amount of matter contained in a body. There are two ways of measuring mass. Traditional way and scientific way. Traditional way, it was by guessing, by comparing the things together and guess it. But scientific way is measured using an instrument called the beam balance. And the SI unit of mass is kilogram. And the non-SI units of mass is like ton, quintal, grams, milligrams, and another things. Now here there's the relationship between the non-SI units. Like for example, 1000 kilogram is equal to 1 ton. 100 kilogram is equal to 1 quintal. 1 kilogram is equal to 1000 gram. 1 gram is equal to 0.001 kilogram. 1 milligram is equal to 0.001 gram. Now let's do an example how to convert the SI units, the non-SI units of mass. Now an example of mass. In one of the pans of a beam balance, the masses 1 kilogram, 500 gram, 30 gram, 0.6 gram are placed to measure the mass of unknown body on the other side of a pan if they are in balance. Now, how to know the total mass of this question? First of all, are they all the same unit? No. Actually, one of them are kilogram and all of them are gram. Now, to find the total mass, we will add all masses, like mass 1 plus mass 2 plus mass 3 plus mass 4 and so on. Now, what we have here, 1 kilogram, 1 kilogram and 500 gram and 30 gram and 0.6 gram. Okay, 1, 2, 3, 4. Now we have 4 masses. We will add them to find the total mass. Okay, but now we can't add them because here what we have kilogram. To convert kilogram to gram, we need to make like the relationship between gram and kilogram. That 1 kilogram is equal to 1000 gram, right? So that means 1 kilogram is equal to 1 kilogram is equal to 1000 gram. So that means we will add 1000 gram plus 500 gram plus 30 gram plus 0.6 gram, which at the end it will be equal to 1530.6 gram, or if we can make it to kilogram, we can convert it into kilogram. Like the final answer for kilogram, it will be 1.50 1.53 kilogram. This is the last two answers. By gram, it will be 1530.6 gram, and by kilogram, it will be 1.53 kilogram. Now let's go to the measuring of time. Now let's continue by the measuring of time. Time, it describes the duration of the beginning and end of an event. And time was described by the people by seeing the sun, how the time can be measured. Like for example, people use the sunrise and sunset as a time measuring device, and this is called sandhya. Okay, the SI unit is second. The non-SI unit of time is hour, minute, day, and also there is microsecond and week, month, year. And also there's something about time. In the past, they used the same thing also, that they measure time by the sunrise. If the sun are if the sun are in the sky and there is a shadow, so that means it is afternoon. And if the sun are not in the sky and there is a small shadow, so that means it is going to be night. And if the sun come like the sunrise, they know that it is the morning. So in the past, people use the same thing, and until now they are using this thing as a device. But now time, we are not seeing the sun. What is the time from it? We are seeing our watch. We are using any devices to know the time, right? By a clock, by a watch, by a digital watch, and other things, right? Now, the non-SI unit of time are 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. 1 day is equal to 24 hours. 1 week is equal to 7 days. 1 month is equal to 30 days. And 1 year is equal to 365 days or 366 days. It depends on the month, on the number of days on the month itself. Okay, now here are some examples how to convert time, like from hour to minute, or from second to hours. And also there are so many things. Also you can convert from week to days, from days to year, from week to year, for year, month to 1 minute, month to minute. You can also convert it, but it will be a large number. Now, here convert the following into minutes. First of all, 1 hour is equal to 60 minutes. Yes, we know about this. But how many minutes if it is 3 hours? 3 hours is equal to how many minutes? Okay, so we will use the crisscross way. Why? Because we already have 1 hour is equal to 60 minutes, but we don't know how many minutes for 3 hours. So When we make a crisscross, it will be t, that means time, is equal to 60 minutes times 3 hours over 1 hour. Yes? Okay. Then when you will cut hour by hour, only what will be left is minute. So that means 60 times 3 is equal to 180 minutes. So that means 3 hour is equal to 180 minutes. Okay, now to the second example, it says 1 hour is equal to 60 minutes. Okay, but we don't know 1.25 hour is equal to how many minutes. So what we'll do here, we'll make the crisscross way again. So when you will make a crisscross, it will come t, which is t, is equal to 1.25 hour times 60 minutes over 1 hour. Now you will cut hour by hour, and then what will be left is 1.25 times 60 minutes. So at the end, it will be time is equal to 75 minutes. 75 minutes. That means 1 hour is equal to 60 minutes, 3 hours is equal to 180 minutes, 1.25 hour is equal to 75 minutes. So that was about how to measure time. But there's also another thing I want to tell you about physics, that as we know that there was a relationship between physics and other sciences, right? Okay, but in physics itself, it have branches. So many branches, like mechanics, electricity and magnetism, heat. There is also astrophysics, as we said before, astrophysics, optics, sound. These things are also branches of physics. And biology also have branches in biology, chemistry. There's also so many branches in chemistry, biology, and physics. But physics, let's study by the branches. Now we will see the branches of physics one by one, but not all. It will be some examples of branches of physics. Now let's go to the branches of physics. Now let's know about the branches of physics. Some branches of physics are like mechanics, sounds, optics, electricity and magnetism, heat, nuclear physics, and astrophysics. First of all, mechanics deals to the to the production, or to say the motion of the body. Okay, deals with the motion of the body. Sound is a production, transmission, and the properties of sound. Optics, the same thing, the production and the transmission and the properties of light. Electricity and magnetism, the relationship between electricity and magnetism in their properties, in the property of body. Heat, heat, it can be the temperature, the the transfer or the exchange of molecular levels. Nuclear physics is dealt with the half interaction of nuclear atoms. Now, astrophysics is dealt with the interaction of like celestial bodies, like for example, galaxies, stars, and planets, and so on, so many things. It's it. So that was about some branches of physics. Not only physics that have some branches, also the same thing with chemistry and biology, and other sciences also have so many relations with the other science, and also have so many branches. Now, in this unit, you know about physics, the meaning of physics, the definition of physics, how can physics help us, and the branches of physics. Okay, and about measurement, that how can we measure the things, and what kind of measurement that we will use it, and why physics are using measurement in their observations. Physical quantities, that we know that physical quantities is the quantities that can be measured directly and indirectly are known as physical quantities. And as we know that physical quantities are classified into two, which is fundamental physical quantities and derived physical quantities. And now here, fundamental physical quantities, we know about how it is measured. It is measured directly, and it's also known as basic physical quantities, also the units which is used to measure, or yes, to measure the physical quantities or the basic quantities, is known as units basic or the basic units. And also we know about the seven fundamental physical quantities and their units, their symbol, the symbol of their units, okay, and their SI units. Derived physical quantities, as we know before, that derived physical quantities, it is measured indirectly, and also the meaning of derived means different. So it's also known as different physical quantities, which is have different units. Like for example, we know some derived physical quantities like area, pressure, acceleration, and so on, and their symbol and their units, and the symbol of their units also. Okay, and about measuring of length, mass, and time, we know how to measure length. And first of all, we know the meaning of length, the definition of length, and also how people are measuring length. Actually, there is also a device like a carpenter. The devices for length, for example, a carpenter. There are so many devices that we can use to measure length. And also the SI unit of length, which is meter, the non-SI units of length altogether, and the relationships between SI unit and non-SI units of length, and we solve an example for length. And the second thing, which is mass, how to measure in mass, and the meaning of mass, how can we use mass in our life, and also it can be measured in two ways, which is traditional way and scientific way. Traditional way, as we said before, it is by guessing and by comparing things together. But by scientific way, it is by an instrument, scientific instrument, which is called beam balance. And we know the SI unit of mass, the non-SI unit of mass, and the relationship between the SI unit and the non-SI units of mass. And we solve also an example of mass, how to convert kilogram to gram, and how to know, like from the question, if there is all gram and there is only 1 kilogram, so that means we will convert 1 kilogram into gram, and we will make it add if we have so many masses. So the total mass, it will be the sum of their masses. Okay, this thing. And the another thing is about time. How, what is the meaning of time, first of all, and how can time help us in our life, and how can we measure time, that it was different between in the past and now, but there is no big difference. But in the past, that the people was using the sun, the sunrise and the sunset, but now the people are using watches and the digital watch, and there's so many things that they can use for time. And also we know the SI unit of time, which is second, and the non-SI units of time all, which is how many minutes in 1 hour, which is 60 minutes, and also 1 hour is equal to how many seconds, 1880. Okay, this is for second, 1 hour. So we can also convert from days to month, from weeks to years. Like for example, as we know before, that 3 hours is equal to how many minutes? 3 hours is equal to 180 minutes. 1.25 hour is equal to 75 minutes. So that was about physics and measurement for today's topic, and I hope that you benefit from this unit and from this video, and you gain a new information about this unit. So inshallah, in the next coming videos we'll make new topics about physics. Thank you for watching and thank you for listening. Goodbye.